All right, let me find a color.
What?
All right, so this is a D block. What can you tell me about K? It's a group 1 and Na. Group 1 and chlorine. Group 17 and F. Group 17 and aluminum. Group 13 would be a P block and neon. It's a noble gas, so group 18. It's easier to write that than noble gas up there. All right, so what was the trend for boiling point?
It's highest in the D block.
Okay, so the D block was greater than P, was greater than group 2, was greater than group 1. Okay, that's what you have to know to answer the question. Are we okay with that? Yes or no?
Yes.
Okay, once you know that, and you've identified this, who is the greatest? Nickel is the answer, because you have something in the D block. All right? Now, I put that in parentheses here because I always forget this. When I teach most reactive, if you will, flip in your notes to yesterday's most reactive. I want you to write that down. Find any notes yesterday where it says most reactive. Wherever you write that down, add in your notes. I want you to add 2 words because I always forget it.
Most reactive to the metals.
Most reactive metals. All right? Now, most reactive metals can also be described as most metallic. So write that down. Most metallic. I don't often use that language, but sometimes tests, other teachers, those of you who might one day have to take this in college, I try to remember to use it periodically. But it's like valence electrons. I tend to use it selectively in various topics. Most metallic also means most reactive. Okay? So if I ask you which metal up there is most metallic, it's the same thing as saying most reactive. So what's the trend for being most reactive for a metal?
The opposite.
The opposite. So group 1 is greater than group 2, which is greater than P, which is greater than D. So which elements are in group 1? K and Na. So if I have 2 of them, what do we do if we have 2 of them? What do we know about the metals? The one that goes down. Okay? So they get more reactive as you go down. So Na, K, who's further down? So K is the answer. Does that make sense? All right, so what's the trend for most reactive nonmetal?
Halogen.
The halogen. So group 17 is more reactive than group 16, more reactive than group 15. So how many do I have in group 17?
2.
I have chlorine and I have fluorine. So I have 2 of them. So what's the rule for nonmetals?
Goes up.
More reactive as you go up. So it has to be F.
Which question was that? 4?
That was 3. All right, so the least reactive metal was the trend.
The transition metal.
Okay, so it's the same trend that's right here. We already wrote down, right? Group 1 greater than group 2, greater than P, greater than D. So who is the least of these?
D.
D, right? So who up there is in D?
Nickel.
Nickel. All right. Which element is just the least reactive? Did I say metal or non-metal? I didn't, did I? I didn't specify. So you got to look at all of them. So who would be the least reactive out of all of them? The noble gases. Okay. Why do we pick the noble gases?
Because they're safe.
They have how many electrons in the outer shell?
8.
They have 8. They don't want to lose. They don't want to gain. All right. And for the last one, the highest density, what's the trend for density?
G1. No, the D one.
The D is greater than P, which is greater than.
G2.
All right. Remember, density, boiling point, and melting point and hardness are all the same. So who would have the greatest density? Yep. Questions? Any questions about that? Any questions? All right, so at this point, you should have 10 openings. It's what, Wednesday? I will give you at most until Monday before I return them, because once I return them, I don't give full credit when you turn them in. Yes, ma'am.
Where's SG at?
Where?
Yeah.
SG is at the very bottom. It's number 106. If you will please, make sure your name's on, because believe it or not, I still get openings that don't have names on them. And please make sure they're numbered or lines drawn between them, something to help me figure out how many openings you actually have. I can. If you have them dated like I can clearly see you have to the side, yes, I can. Okay? But some people don't do that. Their openings run together and I can't figure out which one's which. You know, I count them 2 or 3 times. After that, if you got 9, I just write 90. All right? I'm not going to spend 3 hours trying to decipher or match them up with someone else's openings to figure out how many you have.
I have one opener with no date.
Can you just number them or draw a line between them or something?
I don't know which one it is.
And I'm supposed to figure it out? No. I will do the best I can. That's the best I got for you. And then put them on the stool. Oh, this is the one with the wrinkled paper.
What?
It'll be fine. I can work with it.
It's straightened out though, and they're highlighted, so you don't even have to barely look at the wrinkles.
Okay.
Okay. I'm a vlog.
Hello, Michaela.
Okay, so it's these two.
Oh, I want to there.
I don't care if you rewrite them or if you just attach them and highlight them. Bars and Mace highlighter.
Okay, I'm gonna look and make sure it's right.
What's arsenic symbol?
What you did? What the?
Number?
Let me see, did you get like?
S.
I'm not. Oh my. Oh, Zay, is he being stupid? Because it's almost acted together my brothers.
All right, so do I have all I'm getting?
No.
Come on, hurry up. I'm getting ready to move on, people. I don't have time to wait on open. All right. So we're going to talk about atomic radius, ionic radius, ionization energy, and electronegativity today. Thank you, my dear. The stack is on my desk if you find that you are ready to turn it in. Now, the 4 trends that we're going to do today are the things that you're going to need for your puzzle tomorrow. Now, let me explain how the puzzle will work. You will get a partner. Now, it would be fabulous if all 20 of us were here tomorrow because, you know, it's uncomfortable for someone to have to be odd man out and someone not have a partner. All right?
Can you be my partner?
I don't know. Now,
She's here.
so it's fabulous when all 20 of us are here and all 20 people get partners of 2. You each get, you okay over there?
Almost died.
You didn't almost die, but you might have fallen and cracked your head open on the cabinet. You got the stitches or something.
It's the 23rd.
It is the 23rd. Atomic radius is what we're getting ready to do. Still trends over here, I can.
Oh, so it's
Now.
kind of like.
Wait,
Not a whole new thing, it's just another trend.
Okay, well, I gave y'all.
It's still trends. It's just we're gonna do 4 more.
Very nice and straight it
It is, that's really good.
Trends continue.
Now, so you and your partner will each get to pick a periodic table. I strongly recommend you don't pick the same periodic table. All right? You will probably want one of these that has numbers on it because some of the clues will refer to the protons or the neutrons. And so you will find that you will want one that has numbers for that reason. Now, the other one you may want is one of the ones that we colored because it will refer to things in the solid, the liquid, or the gaseous state. And if you don't remember what a solid is or what a liquid is or which ones are metalloids, that might be the one you and your partner want. if you don't remember the sublevels or which energy levels they're referring to, you might want that periodic table. It really doesn't matter to me which one you pick, but you're limited to only 2 periodic tables. Now, what did I not say you could have? You can't have your reference table, that is true. What else did I not say you could have?
No.
I thought I heard it over there. Notes. You're doing it with 2 periodic tables. So your homework tonight is going to be to do what? Study your notes, because you can't have your notes on the puzzle tomorrow, okay? You get a partner, and you get 2 periodic tables. All right, so if you don't know where the biggest elements are tomorrow when you come in, and it says this element X is bigger than element Y in group such and such, then you can't put the element X in the group based on size, okay? And they're going to be just letters for elements. No, it doesn't say helium is bigger than such and such, okay?
So we're gonna memorize this.
You got to know the notes we're talking about today. You got to know the trends when you come back.
This live is tomorrow,
Yes.
and we gotta remember this in one night.
You still went on your 7 today.
You're in honors chemistry. Now you're in 3 yesterday. You're doing 4 more today. So the 3 that we practiced in the opening were 3. Those were 3. You're doing 4 more today. So you're halfway there, a little under halfway. You're in honors chemistry. You're not in basket weaving. I have complete confidence in you tonight. Half of y'all are taking AT classes.
I'm not including that.
You're in honor chemistry. You can do this. Some of y'all are barely hanging on. I grant you that. All right. However, that does not mitigate the fact that you're not going to do anything.
Oh, I spelled trans T-E-N-D.
Now you're going to force me to go talk to Ms. White again so we can have a good laugh at lunch.
You told her.
I did.
Here talk about the lead.
All the time.
I told her, I said, make sure you ask Michaela about some lead.
I don't know how to act in math, so every time I do something stupid, she's always like, "It's that lead you've been huffing."
Somebody from the second period came up to me and was like, so what's wrong with your first period class not knowing how to number lines?
Oh, they were just as bad. By the way, don't let them throw any shade on y'all. They were just as bad when we tried to do this stuff. Second period was just as bad. Don't let them throw shade. It was just as bad. All right, so in the last chapter, last unit, we had a nucleus, right? And we talked about an orbital. Not a lot of us got it right on the test. It was one of the more missed questions. All right? And we said an orbital, you don't have to draw this, was an area of probability. If you already drew the dot and ink, don't worry, I'm going to come back and draw something else. All right? So an orbital was an area of probability. Can we measure the distance from the nucleus to the outside of an atom and find its radius if it's an area of probability?
No.
No. All right? So we cannot measure the radius that way. So the way scientists do this is we take the nucleus of one atom and just sort of envision that as the area of probability. And we take the nucleus of another atom, try to pretend we're not freshmen, okay? Now, we can measure the distance. I know what they look like, Franco. I need particularly you over there who misbehaves in math class to behave. All right? So, we can measure the
Are we
distance.
supposed to draw this?
You can if you want to.
Just say
So, we measure the distance between 2 identical nuclei. All right, so if we measure the distance between the 2 identical, I should say atomic nuclei there.
Franco, they look like eyes. Why? Get your mind out of the gutter.
It's typically the boys that are worse than the girls, but I don't think so in this class. All right, is the distance between 2 identical atomic nuclei. So, if you're in math class, what would that distance be called?
Diameter.
Exactly, okay? So, we would know that this would be called the diameter. So, if that's diameter and we want radius, what would we do? All right, so you would take 1/2 the distance between two identical or okay, it's half the distance between two identical bonded atoms nuclei.
So that's what the radius equals.
That's what the radius will equal. Now, there are charts and charts of this stuff, which is what y'all graphed last night. Okay? You graphed the radius. We want to talk about what happens on the periodic table, both in a group and in a period.
Now we want to learn it. After we've done the homework.
It shouldn't have been that hard.
It wasn't hard, I just didn't know the answer.
Yeah, because
Google did.
Google didn't have it on one of the worksheets, if you know what I'm saying. No.
I told you you could use any resource but me. I really thought y'all would.
But what?
No, Miss Wall.
Google was useless.
The time that we
Didn't
Googled
we have
Don't
someone to
want
read?
Huh?
On Academy, and I was like, just
There is one, if you Googled the element scavenger hunt, there is one version out there that has two of the answers switched, by the way.
Oh my God.
Okay.
the words
No,
are different, but it's okay. I checked most of them to make sure.
Yeah, there's two of them. Sodium and lithium are backwards.
Sodium and lithium.
Which one is sodium? What's sodium supposed to be? What's sodium supposed to be?
The question that talks about it being on the third floor should be sodium, and on their question, it's usually lithium that they have the answer for. Lithium's on the second floor.
What was the answer for lithium?
I don't know. I'd have to.
Wait, so we were supposed. No.
Did you not believe me when I said you could use any resource other than me?
I don't know what I'm saying.
Okay.
I think I'll do it.
But all the explanations were like, when I Googled it, like why this was the answer, it was too big. That's too smart.
It was too big or too smart.
Elements to look up the colors and stuff.
Oh, I'm not
Like
talking
that helped me, but like not really.
Okay. All right.
Talking about green and orange.
That one I was looking for. I'm like,
H is 1s1. Oh, she's right here. Change her. Oh.
All right. I'm only gonna write 4 of them because it'll give us enough to know the answer, or understand the reasons.
Oh, I did what it was. Is that C for the
Li,
chlorine?
lithium.
This one either.
That was my.
I have to sneeze.
Dude, it hurts.
All right. So if we draw hydrogen, how many rings would hydrogen have? 1. If we draw lithium, how many rings would lithium have?
1, 2.
If we draw sodium, how many rings would it have?
3.
If I drew potassium, it would have how many? So, what happens to the size or the atomic radius of an element as you go down the group?
It gets big.
Okay. So, as you go down a group, the atomic radius increases. This would be question 3 on the homework. As you go down a group, the atomic radius increases because the number of energy levels increases. Okay? That's the reason. Is everybody caught up or do I need to wait? Okay? Are we there now? All right. So, the period trend. So if we do, I'm just going to do period 2. Let's do lithium. Let's do boron. Let's do carbon. Let's do carbon, oxygen, and neon.
Is that a
Yeah. All right. What's the first thing you should notice about this as opposed to the groups?
They have the same,
Same what?
Coefficient.
yeah.
So what's that mean? What's the coefficients tell us?
Energy.
Same energy level. Okay.
Oh, I got the last one.
All right. So, if they all have the same energy level, what's that tell us about size? Is it getting any bigger? No. All right, so we know it's not increasing. But is it getting smaller? How do we know? All right, we look at the protons for this. All right. Lithium has 3 protons. Carbon has 6. Oxygen has 8. And neon has 10. Okay? So, what happens here as the protons pull the electrons closer to the nucleus, as you go across the table, so radius will decrease. So think about the protons almost like a magnet. Okay, y'all have all played with magnets in some science class, maybe at home on the refrigerator. So as the protons get bigger, remember the energy level's not getting bigger, it's staying the same size. So as your protons increase, they're able to pull those electrons closer to the nucleus and make the size smaller. Nice picture. Somebody needs to be on the other side of the room tonight taking a picture. All right, we caught up?
Yeah, we can do it again.
Well,
So yeah, we can explain it again.
so as you go across the table, they're all staying in the same energy level, right? So the ring or the shell is not getting any bigger, but the number of protons are increasing. So think of the protons as a magnet. Okay, so as the magnet gets stronger or bigger, it pulls the electrons closer together, shrinking the size. Okay? All right, we caught up now? Yes, no, need me to wait? So for those of you who are visual people, okay, I like pictures, always have. Probably why I like cartoons when I was little. All right. So, where did we say the atoms got bigger? It gets bigger when you do what? Go down. Okay. So, it increases as you go down. Make that look a little better. Okay. It increases as you go down. Okay, I still don't like the way that looks. Try this way. There. Increase. So as we go across, what happens this way? It gets smaller. I'll write smaller since that's what you said. All right. So you got a periodic table handy? Now, notice I didn't draw the F block because nobody cares about the F block today. It's up to you. I like pictures. Why I'm drawing the pictures. All right. So tell me, looking at that periodic table, who is the absolute biggest element?
FR.
Okay. So FR is the biggest.
What is?
All right. That would be the biggest atom on the periodic table. So the closer you get to FR, the bigger you are. The further you get from FR, the smaller you are. Okay. Who would be the smallest element on the periodic table?
HE.
Uh-huh. HE is the smallest. Now, that's what we just said in words. As you go across, they get smaller. As you go down, they get bigger. Okay? So, you want to do our examples, finding the largest or the smallest element?
Yeah.
Yeah, it's not an answer. Largest or smallest? Eleni, you want to find the largest or the smallest? Okay?
Talking about my secret.
What do you? I feel like the word small is a little bit.
All right. In those three examples, determine who is the smallest.
That's TI.
Yes. No, that's TL.
What?
TL, Valium.
I didn't know there was an option.
Is
I
that
didn't either, but.
Is that what?
Where
Yes,
is that
BR.
at? Oh, I see it, never mind. Valley. Which one is the smallest?
All right, we got it? What'd you notice about the first group of elements?
You're all the same.
They're all in the same who? Group. Okay. So who is the smallest of the group? B, boron. All right. And the second one, what did you notice about those?
Leo.
They're all in the same what?
Period.
Period. Okay. So who's the smallest? BR. All right. And then what did you notice about the third example?
They like the same, like section.
They're in like a square, right? All right, so you got elements in a period and a group. So when you look at them, you have SE, BR, TE, and I. So what happens is you go down. They increases. So those two are out, right? So what happens is you go across. So that means BR. Yes, Franco. Yes. Now this time you have to do lunch attention. Because yesterday was the day we said you use your last one, right? Oh, yesterday was the day we said you use your last one, right?
Yes.
Okay.
They have to go to lunch attention today.
Nope, you just can't go again until you serve.
Not going tomorrow.
All right. So ionic radii is sort of like atomic radii, except ionic radii. All right, board. All right, is about ions. So first of all, what's an ion? What's an ion?
An ion?
Been a while since we talked about them. All right, it's an atom with a charge. Okay, so this could be something like O negative 2, Ca plus 2, Al plus 3, Cl negative 1. Okay? Any of those would be ions. Now, we use two particular words to describe ions. Anybody remember the two particular words to describe them? I'll start with a C, we'll start with an A.
Covalent. Wait, what?
Spell it for me then. Yep. Remember how to spell the other one? Cation and anion. Okay?
I was gonna say what he said.
All right, Zaria, you remember what cation means? Did you remember how to spell it? What? Opposite. Okay, so one with a positive ion or positive charge. It's the positive ion. So that makes the anion the what? The negative ion. And we did this back when we talked about naming for those of you who are like, I don't remember any of this. That's when we did it. All right. So a cation could be like the Ca plus 2 I put up here, or the Al plus 3, or like Na plus 1. The negative ions are the O minus 2 and the Cl minus 1. Okay? Really, are there any lenses in those glasses? Thank God. I kept looking at those.
Because I was tripping like.
I kept looking over there and I'm like, I don't think there are any lenses in those glasses. And I looked again and I was like, I still don't think there are any lenses. Finally, I'm like, I'm just going to ask. It won't be the first time I've asked a stupid question. It won't be the last. I'm assuming you're shooting for nerd today. Okay.
Spaghetti.
Are you saying she can't wear those glasses unless she wants to be a nerd?
I'm assuming she's participating in
I'm
homecoming.
just kidding.
Ain't no worse than your pajama bottoms over there.
That was the point. They feel like they feel like pajama pants too. So who's
Are they pajama pants?
No.
What are they?
Just pants.
Really?
Yeah.
People wore those?
Oh no. There's a reason why I'm wearing them on homecoming week, and you have to wear them.
I mean, if you look back at some of the pictures my mom has of me in the 70s, I mean,
Hey,
people didn't wear stuff like that.
Throwback Day and Nerd Day. Killing two birds with one stone.
You just wear them tomorrow.
No, tomorrow I have a different outfit.
Okay.
That's tomorrow.
Man, I'm
I think it's Throwback Thursday.
Yeah, it is.
Thursday.
I think I'm gonna be extra.
Okay.
I just did cloud.
All right. So if we have oxygen and oxygen -2, okay,
You know.
who's bigger?
-2.
They're the same.
How do we- They're not the same. All right. The key to figuring out who's bigger or who's smaller lies in what we already know. What does this mean?
Oh, you
Add to. What does this mean?
Okay, and you said it meant what?
Add to.
Okay, we added or gained 2 electrons. So think of it as you gain weight. Okay, so if you gain 2 pounds or you gain 2 electrons, what happens to your size?
Get big.
You get bigger.
Increase.
So that means this one will be larger and this one will be the smaller one. All right, by the same token, if you have AL versus AL plus 3, what do you know?
You lose 3 out of that one.
That's right. This one means you lost 3 electrons. So that means what?
It's smaller.
All right, this one will be smaller and this one will be larger. As long as you can keep straight what the plus and the minus means, you should always be able to do ionic radii. Now, catch up and then I'll show you one other thing. And we've got ionic radii covered. That's 2 more. We only have 2 left to do.
Are the other ones long?
Nope, they're opposite of atomic radius. We should have time to practice and either do Plickers or Kahoot today.
Kahoot?
Clickers. What is clickers?
Plickers, it's one of the cards. You know, here the day we did the card?
The one where you got from,
Mhm.
oh yeah. At least I didn't know what that was called. Clickers.
All right, we got it? All right. So the last thing with ionic radii would be something like this. If I gave you Ca plus 2, Mg plus 2, Ba plus 2, and Ra plus 2. All right, which one would be the largest? We'll do largest since we did smallest with Elena's choice a little bit ago. All right, how do we figure it out? If you have that.
Do you go by the atomic number or the mass?
That's what I'm asking you. Elijah,
What's the question?
Down margin.
what can you tell me about all 4 of those choices?
They're all the same.
They're all what? They're all going to lose 2. So what do you know about all of them if they're all going to lose 2? Elijah, I know you know the answer, so I'm not calling on you.
What?
They're all.
They're all
the
what?
Same group.
They're all the same group. Okay? Okay, because they all say plus 2, which Janiyah pointed out to us. Okay? Because they all say plus 2, they're all in the same group. Okay? So, if you put them in order, Mg's at the top, Ca, Ba, and then Ra's at the bottom. So, if they're all in the same group, What did we learn about being in the same group?
The lower you go, the bigger you get.
That's right. So as we go down, they get bigger. So RA has to be the largest. Questions about that?
Yeah.
Bowel problems are a real thing.
Especially in the morning.
IBS.
What?
IBS, irritable bowel syndrome.
That's nice. We don't need to talk about Franco's bowels. Questions about?
So we follow the same rule like that.
We would follow the same rule if they're all in the same group. It doesn't matter that they're ions, we follow the same thing. All right, everybody okay with that?
Yeah.
Doesn't matter that they're an ion, they're in the same group. Farther down is smaller, closer to the top is, farther down is bigger, closer to the top is smaller. Everybody good with that?
Yeah.
All right. So the last two trends, the nice part about them is the trend works the same way, and it's opposite of radius. So I think it makes it easier for us to learn the trend as long as you keep that in mind. All right. The first one is called ionization energy. Okay? Ionization energy. Now, ionization energy is defined as the energy needed to remove one electron from an atom. Now, when I say one electron, I really mean the first electron. Okay? It's the energy needed to remove one electron from an atom, or the first electron from an atom. Now, the reason I point out one electron or the first electron is because we could talk about second ionization energy, and second ionization energy would be the energy needed to do what?
Remove the second
Yes.
electron from the atom.
Okay, third ionization energy would be the energy needed to remove a third electron, fourth electron, so forth and so on. Okay, we're going to talk about ionization energy, but there are second, third, fourth, and fifth ionization energies and so forth and so on. Okay, now, you okay back up there, Franco?
Yes.
Okay.
This will all.
I'm gonna walk in differently when you walk in.
They're worried about you because you were gone for so long. They're worried you had IBS and all kinds of other stuff. They're just concerned after you missed school for so long, and then you go to the bathroom. You can't be missing for any length of time now without them going down a very, very bad path now. They're just worried. I'm just telling you. Your classmates are concerned about you. If you were gone much longer, I think they'd have sent somebody to search for you. You might have been in an ambulance headed for the hospital.
Whoa, what did I say? I saw one.
Listen, honey, it's still smooth.
All right. So a period trend. All right, we're going to start with that. So think about what we already know. We know that on the periodic table, okay?
Does
If
this
we,
go with ionization?
yes, we're talking about the first ionization energy.
Okay, you lost me. Wait,
My favorite thing.
All right. So ionization energy is about the energy to lose an electron, right? Who up here wants to lose an electron?
Everything, wait, no, the first one.
That's right. These folks over here want to lose. Who Who does not want to lose an electron? The
The
far right. Okay. All right, so groups 1 and 2 want to lose. Groups 17 and 18 do not want to lose. So what does that translate to in terms of energy? All right, if you want to lose, is that going to mean low energy or high energy if you're willing to give your electron to anybody?
If you're willing to give it away.
If you're willing to give it away, it means it's easy. So it will be low energy. Anything, for example, is it easier or hard for you to get out of bed in the morning?
Oh, great.
Very difficult. That requires high energy. Okay, you're not one of those people who's a self-starter with getting up out of bed in the morning. It requires a lot of effort for you to get up. High energy. People who are morning people don't require a lot of energy to get out of bed. They're pretty motivated to get out of bed in the morning. Low energy. The vast majority of you people in here are probably going to require a lot of effort and energy to get out of bed in the morning.
A lot.
Anybody a morning person in here? I got one.
Ooh.
Elijah.
Nerd.
Okay? So, people who want to lose electrons mean they are low energy. It's easy for them to give them away. Now, people who don't want to lose electrons and hold them really tightly and are like, oh, no, 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 I'm not giving my electron away, that is going to be high energy. You really got to work to take my electron. Okay? Because I'm not giving it away. Okay? Holding it on tight. You can't have it. All right? Think about it when y'all were little. You had some kind of toy, bear, blanket, something. Nobody could take it from you. You held on to it for dear life. Somebody tried to take it, you screamed bloody murder. Okay? Same concept, except it was electrons. Is that why you put your phone back up there? It was fine on the floor. Wasn't bothering a soul. Now, so if we look at our period trend, all right, as you go across the period, ionization energy will increase because we are closer to an octet, and it is harder to remove an electron. Okay? So as you go across, ionization energy will increase because you're closer to 8. It's harder to take an electron away. Why don't you ask Trevor to move his bag and you just sit in the chair? He seems very nice.
Well, that's not the point.
I was just out of it, distraction.
Someone backed me up over there and said he is very nice.
Cute.
See?
Who?
Trevor.
Oh.
Have you not met Trevor?
No, I have met Trevor. Hey, Trevor. I have a next period with it.
Oh yeah, Ramon.
Ramon.
Your Spanish name is Ramon. Do you get to pick your name or do they assign it?
It just depends.
Right,
It's
depends on what
client
happens.
assigned it sometimes.
Did you get to pick it, Trevor?
You had a list.
Oh, you had a list and you picked it?
Well, I think it was
Lucia,
more
but
kind of
Miss B
bad,
calls me
so-
Pete.
Somebody else picked it.
Oh, what's the list? Listen to Allie's Spanish name.
What's Allie's Spanish name?
It's supposed to be Lucia, but
But Miss B calls me Pete the cat.
P the cat?
Pete the cat. You know the little blue cat?
Remore.
I didn't know who Miss Frizzle was, so.
Okay. Well, basically, it's cartoon cat that Miss B says I look like. So she'll call me Pete. She calls me Pete. So that's what I write on my papers.
How do you say that?
Pink the cat.
Yeah, you look like.
Remove an electron. He's gonna say, Sam, don't even tell me my handwriting's bad. I've seen yours. So shush back there. Don't even come at me with handwriting.
Today not Thursday, is it? Because I had a dream about rushing to get that project.
Yeah, take the hall pass. All right, everybody got it?
It's the 12th.
Everybody caught up?
What if I had a seizure? What would you do?
Call somebody to come down here. I don't have any first aid skills.
The office?
Yeah.
To call the ambulance? Maybe I wouldn't need it.
Let's hope not.
Around your head.
All right, so in a group, what happens in a group?
As you go down,
As you go across, because we're closer to it, like I said, it's better to not want to go. Okay. Okay. The energy goes up as size goes down, and what?
All right, I'm struggling to get K in there. All right, I'll let you catch up with me.
I like your pictures. I love a nice picture.
All right, so what am I trying to illustrate as y'all are catching up? What's happening to the size?
It's getting bigger.
It's getting bigger. So the electrons are getting where? Closer to the middle or farther away?
farther away.
Farther away. So is it easier to take one away if they're farther away or harder?
Easier.
It's easier. Think about it on a field trip. If I'm hydrogen and my little field trip group is really close to me, am I likely to lose any people?
Oh
Let me take 3 of y'all on a field trip. Am I gonna lose 3 people?
no. We go
Not
to
really.
the
I'm pretty good at keeping up with 3 people. All right, but let me say I take all 3 of my classes, which is 80 people. Can I keep up with 80 people?
No, 3 of them are gonna get kidnapped, 2 are gonna die, and that's how it's gonna be.
Probably a likely possibility. Okay, I'm likely to lose the people.
Where we talking?
County dump because I'm not going far. Okay, so
I think I might just.
Oh, that's it. Oh, you were talking about she draws a camera. If that you meant up there. I see.
Every and she painted me one. As size increases,
That's
okay,
sweet.
as size increases, it is easier to remove an electron. So ionization energy will decrease. Okay? Let's say this. All right, ionization energy decreases. Down a group. I didn't write that part.
Do you think you have good memory?
No, my memory's terrible.
I don't see how. I mean, you've been doing this for years, but like, there's so much in one chemistry class. You remember it all. Like, you don't have like a study like. God.
I have moments where I forget some things and I have to look it up.
But
But
still, it's
all right. So my picture people who like the pictures. Okay? Does everybody have what they want? So this is the exact opposite of which one? Which one did I say it was the opposite of? It's the opposite of
radius.
it's the opposite of radius.
I'm not stupid.
Okay? So with this one, what happens as we go across?
It gets bigger. Or
Gets bigger. And as we go down, what happened to ionization energy?
It also, wait, no.
Remember, we're talking ionization energy. So if I go back here, What happened as we go across? Energy did what?
Got smaller.
Increase.
It increased. As we go down, it does what?
Decrease.
It decreases. So it gets smaller. All right, that's why I said it's the opposite of radius. So who is the smallest ionization energy?
The FE.
Far.
Or, yeah, that's the one. That far.
And who is the biggest ionization energy?
So, what was I gonna say? What do you mean bigger? Do you mean like
Largest
Highest.
ionization energy will be the highest.
highest?
Yes.
Because I'm gonna.
Okay. Okay. Everybody got
Wait. This FR.
it? Mm-hmm. All right, we caught up? All right, the last trend is called electronegativity. And we're going to use this in our next unit of bonding. Electronegativity. Fix that R there. And we can abbreviate it EN if you want to, because you'll get tired of writing electro and then negativity. All right, it's a measure of an atom's ability to attract electrons to itself in a bond. It's a measure of an atom's ability to attract electrons to itself in a bond. Okay? So, we're going to talk about I'll let y'all catch up before I talk.
You have so many expo memories. That's a first.
You saw me try to murder me?
I know you just only got 4.
I got you back. Let me
Right
try.
on in there as well. You should have seen.
All right, so if we look at HCl, all right, and I put 2 dots, those are going to represent electrons in the next unit with bonding. All right, who's controlling the electrons? Think about a tug of war, okay? So let's say that we have a tug of war between Zaria and myself, okay? Now, y'all remember how tug of war worked in elementary school? Nobody's picking Zaria. People are picking Miss Wall for obvious reasons. I weigh a lot more than Zaria, so I'm going to be harder to pull across the line, okay? Zaria probably done weigh 100 pounds soaking wet. She might. I take that back. She might. She might weigh 110 pounds soaking wet. Okay? I mean, no disrespect, Zaria, I wish I weighed what you weigh now, but at this moment in time, I just don't. So, huh? Okay. I don't mean to insult you. Okay. My point is, you weigh a lot less than I do. Okay. So, the electrons are the tug of war rope. Hydrogen and chlorine are tugging on those electrons. Who controls those electrons? Who pulls more? So, look at your electrons. Who has outer shell electrons? Look at hydrogen. How many does it have?
Oh, wait, I'm so stupid.
One.
One. Okay. How many does chlorine have?
Oh, wait, no.
So, we know that chlorine wants to gain. Hydrogen wants to lose. So, hydrogen is going to give it away, and chlorine's going to pull, right? So, who's controlling the electrons?
Chlorine.
Chlorine. Okay? So, chlorine pulls or controls the electrons. So, in terms of electronegativity, who would have the bigger number? Chlorine. Okay? So, if we look at the periodic table, the trend is exactly the same as ionization energy. The reasons are the exact same because of the outer shell electrons. They increase as you go across. They decrease as you go down. There's a catch. Okay? The noble gases, right here. Helium, neon, and argon do not have electronegativities. Fluorine is the greatest. Okay? Fluorine is a 4.0. So when you're going across, fluorine is the greatest electronegativity, so you have to stop there. Okay? Now, when we did ionization energy, I'll come right back. Who was the biggest ionization energy? Who was the biggest ionization energy? Say it louder. He. Went all the way across, right? So if I go to electronegativity, who's the biggest electronegativity?
F.
F. You got to stop at the halogens. That's the only catch. Okay? Electronegativity stops there. All right, we're going to practice. All right, Ellen. Hand these out. Hand those out.
What time is it?
9:32.
Would the smallest be for F argon?
Yes. And I'll be right back. Where are you going? Somewhere. I'll be right back. Running away and not coming back.
That's what my mom did. I'm so tired. Did she go back?
So really, if you left through that door, no, she would know this, right?
Huh?
If you left through that door, she would know this, right?
Who won't?
I remember when,
Yeah.
when I left to like go
Back.
clean up my face or whatever, when I was leaving. You realized I was gone. She's like, why are you messing with your notebook? I'm
You're
like,
not grabbing it, you just gonna have it like that.
I know no clothes on.
What?
You can't twist it.
No, I
You
couldn't.
can push it.
If y'all are looking for a good movie on Netflix, Eli is really good.
Well, you was talking about, I done heard you talking about this movie for 2 days straight.
Not as
What?
well.
It's so good.
That's why it's crazy.
Believe
Huh?
it. Like,
Thank you.
cozy and that's what you are.
Everybody get one. If not, you can get it yourself. It's sitting up here.
And I hated his dad, by the way.
Remember that one movie where the son was breaking his dad?
Oh,
Oh, the Johnson.
The strange thing about the Johnson. Bro, that was wild. In the bag. That was wrong.
No, it's not.
It's fucking traumatizing. It's sad.
No.
Everybody gets
It's called Meet the Johnson.
Watch that and I'm
What happened? I remember that. That's right.
Oh, no, it's probably-
That was wild.
What?
Yeah, the son keeps trying to molest his dad.
No, he
does.
He does. How do you get what happened? Like, how does your dad just not even kill you? Because it started from a young age. The dude was freaking masturbating into his dad's picture, and the dad comes in and was like, "Oh, it's okay," because the dad didn't realize he was masturbating to his picture.
Oh, you know, at the end.
Ew, the Johnsons are strange.
All I remember, there was that kid from Amber, you know, China, Amber Clan's brother.
Oh my God,
He played
we love
It was like
You played who?
Oh.
the son in the beginning.
We love y'all right now.
I
would have been like, I will not forget this. I will forget
Yeah, we live.
We all going down.
We used to be have.
Miss Wall don't look bad at this. Nah, she don't. I think
She's
right.
Oh, wait, we're live streaming. Hey guys.
Go say hey to the camera.
Who watching? Ain't nobody should be watching. Who is this one person?
Ain't nobody should be watching.
Was that all right?
You know what? If I had on my Miranda Sings lip gloss, I promise you I'll make a YouTube video on there.
Hey guys, make sure to like the video.
It says there's one person on. Is that us?
Comment what your favorite part was.
Who is just watching? It's not
Ain't you know from out of
Okay, turn push notifications on.
It's just the FBI.
They want to like once.
Oh, which metal is the most reactive? Oh,
Here, y'all tell them done?
no.
Uh-huh.
Here.
How many we got done?
One.
One?
Look here, I was waiting on you to come back because I thought we were
Yeah,
we were waiting.
Don't say that.
Yeah, just really.
It's not right. Non-metals are these things. These ones,
No. Yeah.
right?
Yeah, those are not metals.
All right.
Come on, Lakers, come on.
Like,
I don't know. Ew.
Oh, that sounded good.
Oh, he did not just try to
I
sing.
killed it. I can sing. Sound like Big Brown.
No, that is no way.
Chris Orange.
I didn't even hear what he tried to say.
It
was horrible.
That sounded good.
Clearly it didn't, in most of the classes, but it sounded horrible.
It's like you hate it. It's like you hate it.
Wait.
Oh. 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 Oh.
You better not.
No, CO is the least reactive because it's down at the bottom. If it's all in the same group, it goes increases as it goes down.
Baby.
Okay. Yes.
Oh, it's opposite.
Right now.
This
Okay.
one.
Well, yeah, it is. So I. No. This is confusing. The largest ionization.
What?
We should know. You sound.
That just sounded good.
How? Where's CA?
CA's a group two.
Where's
No.
BA?
Because this is the smallest.
Yeah.
This is the smallest in ionization.
RB's a group one.
Yes.
It's usually
You looking at electronegativity.
Oh, no, I don't know what you're in this.
Oh.
Yeah, Tommy Brady. There's a mosquito flying around, guys, so be careful.
Oh my gosh.
What?
Density and melting point is the opposite of what?
Density and
melting point is the opposite of what?
Reactivity.
Reactivity.
I don't know if I said this.
Where's our
26.
Hey, Michaela,
Huh?
what are you doing?
Have a good time.
I think it's minus for a bit, or wait.
What are you doing for the?
Not having a good time.
Why not?
Having chemistry class.
Oh, you don't like it?
I'm kidding. This one. I'm kidding.
A is,
You make this class.
yeah,
Where's phosphorus?
Chemistry class.
Oh, I see.
as you go across, it gets smaller. Yeah. Wait, no, or as you go down, it goes smaller. No, as you go down, it gets bigger.
Which element has 4 outer cellular forces?
It's not K.
Where's the A? 14.
Or wait, it might have to go.
Wait, I'm looking
It's right under K.
Which element? Plus 3.
It's hard.
A plus 3 ion, is that asking for which one has like a plus 3, like
Oxidation number?
or a
Yeah.
minus 3?
Nope, plus 3 oxidation number.
So it's over here. Right, it's on this side. It's which element has a higher
Plus 1.
Plus
2.
plus
Plus
3. And then 4, minus 3, minus 3.
Yep.
I'm so smart.
4 out of 12. 1, 2, 3, 4.
Aluminum it is. Which element is the largest?
PPD.
Okay.
Oh, because it goes into the FR. Then small ionization.
Where's CS? Oh, never mind, I see it.
I.
I did it. Are we turning this in or no? Never mind, I don't even know I asked that. We don't ever turn that glass part really, unless it's like a partner thing.
Hey, John, the Emmett Lyon tried to say that Canada was a New England state.
What?
That's the dumbest thing I've
That reminds me of when
all
Toronto
day.
Who said Canada was a New England state?
Emmett Chevalier.
Who?
Emmett Chevalier.
Emma.
Why'd she say that?
She's
Oh, well, we were guessing like New England states for some reason. I forget what it was. This is true.
Manchester.
And she was like, Canada. Yeah, they turned out to be like she's pretty not smart.
It's not very nice.
So,
Sorry.
Miss Wall, this says one person is on, or is that us?
Oh!
It says
You burning people up?
it has the people icon. It says one next to it. Is that us or somebody else watching? Somebody else shouldn't be watching.
Franco, why are you running ahead, man?
You got Miss
But Miss
Carl.
Harvey said, "Yeah, I don't know about them headbands. I haven't made my decision yet." So
I feel like we should just not let her just make
so
up
she makes a
rules.
decision.
Well, You can wear it today because the sun coming, but
Yeah.
she still said no headbands to me. All right, yeah, she
It
did.
completes my referee uniform.
It's,
Oh,
referee
you're right.
uniform is okay. Beyond that, no. All right, which metal is the most? Because I can't tell the princess to take off her scarf and then let you wear a headband on a normal day. Okay.
Yeah.
Then what, you want me to do?
No, it's part of the referee uniform today,
Yeah, definitely.
but tomorrow, no.
I mean, I wear this a lot of referees.
That's fine. That's what I said. It's part of the uniform today, but on a normal day, it's a no. All right, so number one, which
Yes,
metal is? What are you doing?
I've been trying to do that every day.
This would be what Ms. White complains about, right?
Yeah.
She said that you act like a fool in her class and asked me, did she do this in your class? And I'm like, no. And she said you're like nuts in her class.
I'm not nuts.
Okay, well, I believe you are.
Yeah.
Hey, Michaela.
It's just like, we're all delusional. Like,
It's because it's the end of the day and we have work still to do. And my brain can't do actual work, so it has to make up for something.
Oh, okay, so number one, which one is most reactive?
I felt that.
Check your pencil.
It's SR, okay? There's no group one element, so you have to pick group two. Magnesium and strontium are both in group two, so what happens is you go down. It gets more reactive, so SR. All right, so which non-metal is least reactive? I. Are we okay with I?
Yeah.
All right, number two, which element has the largest ionization energy out of those? AR. Okay. Number four, which atom or ion is the smallest?
T plus 5.
Plus 5, because you lost 5 pounds. Okay. I need to do that myself. Which element has the smallest atomic radius?
Ca.
Ca. You okay with Ca? All right. Which element has the largest melting point?
Fe.
Fe. Yes. Okay. Which element has the 4 outer shell electrons?
Lead.
Pb. Lead.
Not-
It is not in your pencil. Don't start with that crap again. All right. So number 8. Which element will form a +3 ion?
Aluminium.
Aluminium or aluminum, however you want to say it. It doesn't matter to me because I'm trying to line it up and not doing a very good job. All right. Which element has the largest atomic radius out of those choices?
Okay.
K.
Potassium. Like in
Potassium.
my banana. Was that wrong?
No, it was just the accent in the statement. All right. Which element has the smallest ionization energy? CS is correct.
I have a banana.
All right. Questions about any of those?
Yes.
Why is it CS?
Yes, no?
Why is it CS?
Okay, because when you, I don't think I can write on this thing. When they redid it, I don't know if it gave me access to be able to do it. I can try it. Oh, it did. It's a miracle. Now where's the eraser thing at again? There. All right, so ionization energy, if you go across, increases. Okay, clearly
You can
that's
see it
not.
up here.
It's a boat.
All right, so it increases if you go across this way, and if you go down, it decreases. So I have elements of Cl over there. Okay, maybe not. Cl, Si. It doesn't like me. All
This is
right,
how much life feels because her boy is bored.
Na, and then Cs down here. So if I go across, they increase. I'll lay this down so Zaria can see. So Na, Si, and Cl, they get bigger as I go that way, right? And as I go down, Cs gets smaller. Does that make sense? Anybody else? Question about anything on the 1 through 10? How am I on time? I have 6 minutes. I don't think we got time to do flickers. We don't.
You go to them fast.
Yeah. You can tire y'all's attitude. Number 5.
What happened?
Get crazy.
What did he say?
All right, so that's the trend, right? Decrease and then increase for size. All right, so for number 5, these are all in a square. So you have SR, and you have CA, and then RB, and then K. And it wants to know smallest. So these are going to be bigger. And so as you go across, they get smaller, so that's why it's CA. Anybody else question on any of 1 through 10? All right. Do you want another sheet to practice before the lab tomorrow?
Yes.
Okay, we might get to the quiz tomorrow, we might not. It's gonna depend on time. Okay?
Boy, shooter. Sure, you.
Shooter. Miss Wall, is there any coworkers that you hate?
Yeah, but I wouldn't tell you who they
Or
are.
not? We'll keep it there.
I bet I know. It's
Right.
Curtis.
I would never tell teenagers something like that.
Wow.
Well, when we're at therapy together, I mean, we're gonna have all open it.
You are ridiculous.
Hey, Miss Kurt, do you think Miss Kurt watching
We'll just have a pen on that to bring there.
Not today, though. That's how you left.
When she's like our number one fan. She's like,
What is this?
they're all just watching.
Is anyone going on the Atlanta trip?
I might.
I want to, but she got 6 spots on the
Is what?
sign up, so I'm just going to office like him.
Me too.
So is it to add to your nerve function study? Okay, cool.
I'm gonna give up my name.
What do y'all do?
Give up my name.
Yeah.
She made me sign up.
And what are you signing up to do? See?
No, I wish I was. I want to be on the,
No.
I want to be on the fire.
Right, and I was like,
I tried to sing it and it didn't come out.
Y'all put your butts in a chair.
I can sing for real.
Whoa.
And you probably can't even write it down. So then you go back to her and be like, you were supposed to write my name down. What's your beef with that? Like, you know, I came in here. I want to watch that movie all over again. When I watch movies on Netflix.
Put your butts in a chair.
When I watch movies on Netflix, I have to turn on the music when scary parts come on.
Like, what was the scary movie?
Eli.
Was it good?
Yes. Yes. I cannot watch scary